Section 2.5 is literal equations and formulas. I can rewrite and use literal equations and formulas. Big ideas here. A literal equation is an equation that involves two or more variables. The solution of a literal equation can be found using the properties of equality to form a series of simpler equations. And the properties of equality can be used repeatedly to isolate any particular variable. So in example 1 here, we're going to rewrite a literal equation. The equation 10x plus 5y equals 80, where x is the number of pizzas and y is the number of sandwiches, models the problem in the solve it on the top of page 109. How many sandwiches can we buy if we buy 3 pizzas or 6 pizzas? So the first thing I'm going to do here is, since we're looking for how many sandwiches, I'm going to solve my equation here for sandwiches, and y is the number of sandwiches. So I'm going to try and get y by itself, and in order to get it by itself, we have to figure out what's happening to it. Well, it's being multiplied and it's being added. So if we look at PEMDAS, we're still going to work backwards to solve. We don't have any subtraction to get rid of. We do have addition to get rid of. And it doesn't matter that there's an x with that 10. We're still going to get rid of it the same way. So right now I have positive 10. I'm trying to get it to 0 so I don't have any of that term on my side of the equation. So I do the opposite and I subtract 10x. And whatever I do to one side, I still do to both. Keep in mind, we're moving that entire term. So I'm getting rid of the entire 10x. So it's a 10x on my other side. So now I have 5y equals 80 minus 10x. And I can't put the 80 and the 10 together because they're not like terms. The 80 does not have an x, the 10 does. So we got rid of our addition. There's no division, but I do have multiplication. So now I get rid of my multiplication. To get rid of multiplying by 5, I divide by 5, and I do that on both sides completely. I divide both sides completely to get rid of my multiplication. Here, I'm going to distribute that division to both pieces. So I'm going to take 80 divided by 5 and 10 divided by 5x. So I'm really going to get y equals 16 minus 2x. And now we know our equation in terms of sandwiches. Remember, we're looking for how many sandwiches, and y is the number of sandwiches. So the number of sandwiches is going to be 16 minus 2 times x, and x is the number of pizzas. So if we wanted to buy 3 pizzas and figure out how many sandwiches, I could plug a 3 in for x, because x is my number of pizzas. So the number of sandwiches is going to be 10 sandwiches. If there are 3 pizzas. If we had 6 pizzas, I'm going to plug a 6 in for x. And here I'm going to get 4 sandwiches. And we could have gotten there by plugging in 6 and 3 into our original equation and solving both times. But there we have to do those steps, the adding or subtracting, the multiplying or dividing every time. And here we can just simplify. So we just plug it in and simplify. So if we solve right away for the variable we're looking for, and again, this is a literal equation because it's got more letters in it, then it's a little bit easier to solve in and find multiple values. Now we're going to solve the equation 4 equals 2m minus 5n for m. And then we're going to figure out the values of m when n equals -2, 0, and 2. So first step is we are going to solve our equation for m. So I'm going to box in my m so I remember what I'm looking for. M has subtraction with it and multiplication. So I'm going to get rid of my subtraction first. In order to get rid of subtraction, we add. Whatever I do to one side, I do to both. And it doesn't matter that there's an n with it, guys. It's still being subtracted by 5n, just like if it was subtracted by 5. We get rid of it the same way. So -5 of something plus 5 of something, even though they're n's, still gets us to 0. And whatever we do to one side, we've got to do to both. So here, 4 plus 5n equals 2m. And I can't put my 4 and 5 together because they're not like terms. With literal equations, guys, it's really helpful if we box in or circle or highlight or something the variable we're looking for, because here we have more than one letter. So to make sure we keep the one that we're looking for here for m, it's very helpful if we box that in or circle it or highlight it or something. Now we check what's happening to my m. It's still being multiplied by 2, so I get rid of multiplication by division. And again, we can divide the entire thing by 2. Both sides completely. Here I can distribute that division. And we talked about that in chapter 1. So I can take 4 divided by 2 plus 5n divided by 2, which gives me 2 plus 2.5 n equals m, or you could leave it as 5 over 2 because that doesn't simplify. So here I have solved it for m, and that's the first thing it wanted me to do. Now, what are the values of m when n is negative 2, 0, and 2? Well, for negative 2, I plug in negative 2. And simplify. M is negative 3. For 0, I plug in 0 for n. (2.5 times 0 is 0). So 2 equals m. And the last one is n equals 2. So for n equals 2, I plug in 2. And I get 7 for m. And that's a lot faster, quicker, and easier than it would have been if we just substituted in to our original equation and then had to solve for m every time. So solving our literal equation for the variable we're looking for a lot of times is going to be helpful. When we rewrite literal equations, we may have to divide by a variable or variable expression. When we do so in this lesson, assume the variable or variable expression is not equal to 0, because we can't divide by 0, so we have to make sure that we're not trying to do that. So we're just going to assume that whatever we're dividing by is not 0 for now. So in example 2, we're going to solve ax minus bx equals c for x. So I'm going to go through and circle all my x's, or box in all my x's. Now, we have to combine any like terms that we have. So if we look at this, we can think about it like a simpler problem. That's one of our problem-solving strategies. If this was 5x minus 3x equals 7, we would combine our like terms by not worrying about our variables and just taking the 5 minus 3, our coefficients, subtracting them and getting the 2x, keeping our variable exactly as it's written, and then performing the operations on our number parts. I would take the 5 minus 3 times x, or just 2x, equals 7. We can do the same thing here with the a and the b. The only difference is we can't go from this step to this step because we don't actually know what a minus b is. But I can still take out my x and then perform my operations on my coefficients, a minus b. And like I said, we just don't know what a minus b is, so we knew 5 minus 3 was 2. We don't know a minus b, so there's nothing else we can do to simplify that. But I am still trying to get x by itself. So over here, to get x by itself, it's being multiplied. I would divide both sides by the 2. We can do the same thing over here, even though it's a difference. I can take and divide by a minus b on both sides. X is being multiplied by a difference, so we divide by it. Whatever it's being multiplied by, we divide. Anything, so a minus b divided by a minus b, anything divided by itself, no matter how complicated, is always just going to be 1, and 1 times x is always x. So I get c divided by a minus b. Just like over here, I got 7 divided by 5 minus 3, which is just 2. So if you get to these guys and you're like, I'm not sure what to do, Solve a simpler problem. Plug in different numbers for each variable. So here I said A was 5, B was 3, C was 7. See what operations we could do to solve it with numbers, and then do the same thing with your literal equations. Because remember, numbers and letters are just symbols. They just represent unknown quantities. So don't get confused. When there's more letters there, they're still just symbols. We could use Pac-Mans and ponies too if we wanted. Now feel free to pause here and give this a try if you'd like. We're going to solve for x. And if we look here, I only have one x, so I don't have to worry about combining like terms. I'm just going to solve by undoing my operations. And again, we use PEMDAS backwards. Right now I have no subtraction, have some addition. Right now I have a positive r I need to get rid of. And I get rid of a positive by subtracting, because remember, we're trying to get it to be to 0. Right now I have one r. If I take away an r, I have no r's left on the same side as my x. And we're trying to get x by itself because that's what we're solving for. The minus t minus r, there's nothing I can do there to put those together because they're not the same variable. If they'd have both been the same variable, we could have subtracted. But they're not, so we have to leave them separate. They do not have the exact same variable part. Now, we're still solving for x. X is being multiplied. We get rid of multiplication by dividing. So I'm going to go ahead and divide by p. So I can leave this as negative t minus r all divided by p equals x, because nothing simplifies there. Or I could take negative t divided by p minus r over p equals x. Either one of these work. And to get here, I just distributed that division. I took it to both pieces. And again, we can leave it over here if we want to, because there's no p's on the top, so we can't simplify it all. So again, figure out what variable you're looking for, what operations are happening to it, and get rid of them the same way we would if these were 2's, 3's, and 4's instead of t's, r's, and p's. A formula is an equation that states a relationship among quantities. Formulas are special types of literal equations. Some common formulas are listed on page 110, and those are going to be things that we're going to use throughout the year. Things like area of a circle, perimeter of a rectangle, distance equals rate times time. That's a really common one we're going to use a lot, or dirt formula. So those are going to be things you're going to want to become familiar with. What is the radius of a circle with circumference 64 feet? So here we're talking about circles, radius, and circumference. So the formula we're going to use is circumference of a circle equals 2 pi r. And we want to know what is the radius, so we're going to solve for r. Right now r is being multiplied by a 2 and by a pi. So I'm going to divide, to get rid of my multiplication, by a 2 and a pi. Keep in mind that the fraction bar, 2 divided by 2 is 1, pi divided by pi is 1. Fraction bar is a grouping symbol, so when you go to type this in your calculator, you're going to have to put in parentheses there. Okay, we don't need to write it with parentheses because our fraction bar is our grouping symbol, but when you type it in your calculator, you're going to take your circumference divided by, in parentheses, 2 times pi equals. Now, we want to know what is the radius with a circumference of 64, so I'm going to plug 64 in for my circumference. And it says round to the nearest tenth. So when I type this in my calculator, I get my radius to be approximately 10.185916. So to the nearest tenth means one decimal place. I look here, one digit past where I'm trying to round to. So I look at the 8. 8 rounds up. So my radius is approximately 10.2, and this is feet. And again, 5 or higher rounds up, 4 or lower rounds down. So we solved our literal equation, an equation that has more than one letter in it, for what we were looking for. Here we were looking for radius, so we solved for r, and then from there solved further. And I will finish this section in another video.